Okay, we're going to look at, from this Core 2 paper, January 2013, question 4, one of these solving trig equations ones where it's, in this case, cos of a function equals a value. And just as important as the question to solve is the range of values for x that we're going to get our answer in. So in this case, x is between 0 and 180. Now, what we have to do is, I think is a good step to rewrite this function, but using this to actually change our range, and then we can consider all the values in the range. I'm going to sort of think about it by looking at the graph. 0 to 180 is only half of a full cos curve, so I've got y equals cos x, starts up there, goes through 90 and finishes, as it were, down at 180 at the bottom there, and cos of 180 is minus 1. Now, when we look at the cos of the function in the question, the 3x minus 10, we'll do it in two stages. We're going to do cos 3x first, and remember what it actually is bracketed. So what that 3 is doing, because it's within the brackets, is the opposite. It's not timesing by 3, it's divided by 3. I'm squishing the curve itself. And what I actually got here, hopefully, I've done it in such a way that I know I'm going to do this, bottom out here, do that, top out there, cross there, and do that. So instead of having half a curve, I've got 1 and a half. I've got 3 times as many, basically. I've got crossing at 90, finishing at 180, and so on like that. And all the minus 10 does, in the brackets again, is the opposite of what we think. It shows the curve 10 degrees that way. So it's going to sort of start up here and do a little bit of a quick sort of 10 degrees there, like that, and top out, cross at 40 in this case, bottom out at 70, cross at 100, top out at 130 instead of 120, cross at 160, and then be part way down there, like that. And that's at my 180 there. And that's gone 10 degrees that way, and that's gone 10 degrees from what it was before, and so on. So bit by bit, I've got my original part of the curve, I've squished it by a factor of 3, and I've shoved it 10 degrees that way. What it's telling me is this: if I consider the question cos 3x minus 10 equals minus 0.4, if I find y equals minus 0.4 on my graph, about there, and go along, it's given me 3 solutions. So I'm going to try and find 3 solutions. So let's go back to the question itself and find my 3 answers. Okay. So the reason giving me 3 answers is because when I do the inverse cos of minus 0.4, there's only one answer in 0 to 180. Okay, so let's look at our calculators. Make sure we've got D for degrees, because it's got degrees in the question, and do shift cos minus 0.4, close brackets, equals. So one answer is 113, and I'll keep it there, 0.5, so on like that, because I'm going to be doing stuff with it to actually solve it. And that equals 3x minus 10. So one of the answers will be when I solve that equation there for x. But what I'm actually going to do is find all the answers in this new range for 3x minus 10 by times it by 3, 0 to 540, and taking 10 off like that to 530. So one answer is that one. My second answer is, how do you find the second value 0 to 360? You take that answer away from 360, so it's going to be 360 minus my answer, which is 246.4, something like that. And my third answer, everything repeats every 360. So if I keep adding 360s onto this until I'm outside of my range, that'll do the job. So if I have my 360 plus my 113.5, whatever it was, 473.5, like that, that does the job there, because adding 360 onto this one gives me roughly 600. It's out of my range. This will lead to my 3 solutions, and all I have to do now in each case is undo this function here, which is add 10, and then divide by 3 for each of those 3, and that's my 3 answers. Okay, you're going to get your first one for doing this and undoing it, so 1, 2, 3.5, divided by 3, which is roughly 41.2. 246.5 plus 10, 0.4 divided by 3, and that gives me my second answer of 85.5, and my 483.5. Once I've added 10 to it and then divide by 3, gives me that answer there of 161.2. Those are my three answers. If I go back to my graph and have a consider there we go, just over 40, looks about right, below 100, and just over 160. So using my rough sketch there, I can see that that matches up really well with my three answers that I've got there. Okay, so bit by bit then, what we do, well, we've got sin, cos, tan of a function, range of values for x, rewrite the function. That's telling you that I'm going to get probably more answers than I'm expecting. Your calculator's only going to give you one, that one. You've got to be able to use the range to find all the others within that range there. Okay, and so it's either, if it's sin, they either add up to 180 if it's positive, they add up to 540 if it's negative, cos, they add up to 360, tan, everything repeats every 180, and then if you need more than two, how do you get all the others? Keep adding 360s on, or taking 360s off if it needs to go the other way. And then bit by bit you've got all your solutions, and the last thing you do once you've got all those values is then undo the function. I don't undo the function to get that, then take that away from 360. I find all the values first, and then undo the function last, and that gives me all my answers there.